In statistics, z-scores are a very important measure. The z-scores are just another way of identifying number of standard deviations. We learned from the empirical rule earlier that plus or minus 3 standard deviations from the mean or average usually accounts for almost 100% of all of the data in any data set. This makes z-scores a very important tool that statisticians use in evaluating various data sets. In this particular example, we're looking at a list of 10 numbers. And if we were to calculate the z-score, for example, on the number 7, there would be a manual formula that we could use, or we could actually use one of the functions in Excel to do the calculation for us. We're going to do it both ways so you can see how it's done. I've already calculated the mean at 11.2 by using the function average in Excel. We've done that before. The standard deviation was also calculated using the function in Excel of stddev, and you see that we have the results of both of those functions listed. The average or mean of this group of data is 11.2. The standard deviation is 2.49. The manual formula to calculate is shown now on the left-hand side. And it's telling us that the z-score equal x sub 1, which is the number of interest. In this case, we said we were going to calculate the z-score for 7, so that will be x.1. Minus x with the line over it, and if you'll remember, that stands for the mean, which we now know is 11.2, divided by the standard deviation, which we've also calculated, which is 2.49. So I'm going to move over now the actual manual calculation that we would go through. And what this shows you is that we have substituted the 7 for x1, we have substituted the 11.2 for the required mean, and we've divided by 249. When we finish our calculation, we have negative 4.2 divided by 2.49, and we end up with a result of negative 1.69. So that would be our manual calculation using the formula. There is also the statistical function in Excel called standardize. And if we start typing standardize in equal standardize, double click on it, you will see that it asks for 3 pieces of information. First is the number that we're interested in, and in this case that's going to be 7. And we'll put in a comma and then give them the mean, and we'll again just highlight the 11.2. And then lastly the standard deviation, which we'll highlight as the 2.49. When we enter that, you will see that it returns a result of 1.6897, which would round, of course, to 1.69, negative 1.69, the same as we got when we used the manual formula. This bell curve you should be familiar with by now because it represents the graph that's made by most data sets. This particular one is illustrating standard deviation along the bottom. If you recall, the Greek letter U here stands for the average or the mean. If we went plus 1 standard deviation to minus 1 standard deviation, we would see that typically, according to the empirical rule, that 68.2% approximately of all of the data falls plus or minus 1 standard deviation. If we went to 2 standard deviations, you would see that it's adding about another 27%, and we would be looking at about 95.4% of all of the data now falling plus or minus 2 standard deviations. Lastly, if we went all the way to 3 standard deviations, plus or minus, you would see that about 99.7% of all of the demand would be, or all of the data, I should say, would be accounted for plus or minus 3 standard deviations. And this has been borne out over and over again, and is a rule that statisticians count on as being able to help them to use information from a database, Z-scores especially, to understand the probability of something happening. And that's an important point, because moving forward, we're going to take a look at what the relationship between the Z-score and probability looks like and how it can be used in statistics. The last piece that I'd like to demonstrate for you is that there is a relationship between Z-scores. Remember, Z are standard deviations, and the probability of a number that's at a particular Z-score coming up. And so let's take a look at 2 things. First, if you have the Z-score, and we do, negative 1.689 and so forth, we can use that Z-score to calculate the probability. Remember, that Z-score represents the Z-score for the number 7 out of the database that's listed above. In order to do that, we're going to use the function in Excel, norm SDIST. We're going to click on it, and it's going to ask us for the Z-score in the drop-down menu, and rather than type that in, we will just highlight it, and when we push enter, you'll see that Excel returns 0.0455, approximately 4.5% probability for number 7. And the last thing would be the inverse of that. If you were looking to solve a problem where you had a probability percentage and you wanted to understand what Z-score corresponded to that, you would use the inverse function, which in this case would equal norm SINV, which standing for the inverse. And in this case, we would highlight, as it asks for, the probability, which is what we just figured above. And then when you hit enter, it would return the standard Z-score for the number 7, 1.689 and so forth. And as you can see, that is exactly the same number that we got before. The things that are demonstrated in this video are very important in many statistical calculations. So it's really important to get not only familiar with what they are, but to get to the point where you feel comfortable using Excel to come up with your answers. There are, by the way, a large number of Z-score tables that you can download from the internet that would help you to look up either probability or Z-score if you did not have the availability or the knowledge on how to use your computer.